So I'm going to talk about localization of p-adic Frobenioids. So this is example 1.4 from Frobenioids 2. So we're going to say let f be a number field. We're going to say f tilde is going to be an algebraic closure. We're going to take v in spec OF and view it as a valuation. So we'll say that this is the same thing as the valuations of f minus the valuations of f over the infinite valuation in Q. And then we're going to take fv to be the completion. And this is also going to be a completion. Okay, so there's the functor that I want to describe is this guy here. So this goes from covers of f, so these connected covers, to plain old covers. So this isn't so this is the localization map for Frobenioids. So Mochizuki writes this as here. Then he takes this symbol. This symbol means so you take a closure under coproducts. So here you can see that you will have something that's disconnected. Oh, F. So we have something that's disconnected. So we'll have something. Okay. We'll get something that's disconnected, but it's the same thing as having something, taking something connected and then taking coproducts of connected things. And so it's just like a disjoint unit thing. I don't know why he does that. And so this map is really pull back a cover. I'm going to describe this map in two different ways. So the first description comes from groups. So there's a way to describe, let's just go with Q and QP. So the covers of Q, okay, this connected thing. So these are really the same thing as the category of G sets, so connected G sets. So this is one of the viewpoints he has. Same thing with QP. So we have, finite GP sets here. So these two dudes are categories of connected G sets. Okay, finite sets, and then the inclusion GQP into GQ shows how a GQ set can become a GQP set. You just kind of restrict the action. Okay, so that's one way of doing it. If you don't like that way, there's another description. And this is the kind of standard one. We'll take a cover of, say, spec Q, and we just pull it back as normal. Okay, so we pull back. Okay. So the only thing that really matters in this construction, I think, is that there is an inclusion of fields. Maybe someone can say something more about this. Okay, so this is kind of bad because back here, the covers are no longer connected. So we're pulling back no longer connected. Okay, so that's not good. And so what do we do? So we were going to make a new definition that fixes this. So definition So this is page 12 of Geometry of Frobenioids 2. Still the same thing. What we're going to do is we're going to define these covers, and so these are going to be connected finite tall coverings of spec FV with a localization map. Okay, so how do so to define the category, I need to define the objects and the morphism. So the objects here are going to be P, Q, and these maps from I, P to rho, P, Q. Okay, so I should denote the prime here. Oh, I did. So I denoted the prime in the localization map. Okay, so these are these things. So I should say what P is. P is a cover of QP, and Q is a cover of Q. Oh, sorry, let's not do Q and QP. Let's do FV and F. Okay, so then the morphisms. So these are morphisms of covers here, alpha to P prime, Q, so they're pairs like this, to Q prime, such that, and then I'm just going to draw a diagram. So P goes to P prime, and then we have this localization rho here, or sorry, I, and it goes to rho P of Q prime, and then we have rho P of Q, and this thing is, sorry, rho P of beta, this is rho of alpha. Okay, and we have this I and I prime. Okay, so we have these two things, and the morphisms need to do this. So building a category like this, it tells us how we can localize certain Frobenioids. So I guess using this idea, he says that, for example, in example 1.4 part 3 of Frobenioids 2, he says the main results from from Frobenioids 1, so I think these are arithmetic Frobenioids, can be applied to p-adic Frobenioids. So my question is, so maybe you guys can answer this, is does this include the degree trick? Let's call it the degree realification trick for arithmetic, or Frobenioids of arithmetic origin.